So welcome everyone. Thank you for joining us in this webinar today about the role of artificial intelligence in energy management. We are here representing Spacewell Energy. So what are we going to talk about today? We are going to provide you with a brief introduction about the company, Spacewell Energy, for you to have a bit of context in case you are not a partner yet about the company. Then we will go through an overview of artificial intelligence and machine learning, applying it to the field of energy efficiency. Don't worry, no prior knowledge is required in order to attend to this webinar. Then we will walk you through a practical case of a tool that we developed here in-house about forecasting energy. And finally, we will show you other AI applications that we offer within our offering. So today with you, the speakers today are...
Hello. I'm Alfonso Mateos, Product Director here at Spacewell Energy. Thank you for joining us.
I'm Julia Vallascas, Product Manager here in Spacewell Energy. And we are here in Spacewell Energy offices in Barcelona. And we have an amazing guest from the UK, Kashif Mugiz. If you want to introduce yourself.
Yeah, thanks, Julia. Thank you for joining us today. So what will be an insightful session on how AI is transforming energy management. My name is Kashif Mugiz. I'm Senior Account Executive at Spacewell Energy, part of the Nemetschek Group. And with over a decade of experience in smart buildings, IoT, and energy management, I've worked with organizations across various industries to help them leverage data and technology to drive efficiency, reduce costs, and meet their sustainability goals. Today, we'll explore practical real-world applications of AI in energy management and how your organization can harness data-driven insights to make smart, more proactive decisions. Before we dive into the details, let me introduce you to Spacewell Energy and our parent company, Nemetschek Group. So I'll just move it to the next slide. Right, so here we are. The Nemetschek Group is a global leader in digital transformation for the built environment, providing innovative solutions across the architectural, engineering, construction, and operations industry, from designing and building properties to managing on optimizing their performance. Nemetschek helps organizations work smarter, more efficiently, and sustainably. As part of this group, Spacewell Energy, we are in the operate and manage segment of Nemetschek Group, and we specialize in intelligent energy management solutions. Our platform helps organizations turn complex data into clear, actionable insights, enabling them to optimize consumption and reduce energy waste, lower operational cost, and improve sustainability performance. And then let me just move to the next slide. We also want to share a bit more about Spacewell. So, at Spacewell, we've been in business over 30 years now with 100,000 connected buildings, 5,000 plus customers, have 7 offices, and within our portfolio, on top of energy management, we have other solutions as well, like workplace analytics, occupancy, space level monitoring as well. Also, as an independent organization, Verdantix, they've classed us as leaders in their latest Green Quadrant report, which highlights our technological innovation, advanced analytics, and real business impact. Now, without further ado, I'll pass it over to my colleagues, Julia and Alfonso, who will walk you through the technology in detail and demonstrate how our AI-powered solutions can benefit your organization. So over to you, Julia. And Alfonso.
Thank you very much. So let's start from the beginning. What is artificial intelligence?
Question. What is artificial intelligence? Well, ChatGPT, maybe?
We would like the audience to think about this question. What is artificial intelligence for you, or what do you understand by artificial intelligence? ChatGPT is the most famous one, I would say, lately.
But we've been doing artificial intelligence for a while, in fact.
Yeah.
Several years here in Spacewell Energy. So It seems like it's something super new, but we've been using artificial intelligence for years, not only in spatial energy, but in our common tasks.
Right? That's right. And actually, artificial intelligence has been around for so long, but its popularity, according to Google Trends, starts when ChatGPT was launched at the end of 2022. And this axis, y-axis is our percentage. So you see how the interest raised from the beginning of 2023. And actually, the main public has read and heard a lot about artificial intelligence last year. If you look for AI and you filter by news, in the last 12 months, Google provides 577 million results. So we have been like attacked by millions of articles and news regarding AI. I don't know about you, I've heard like about everything already.
Yeah, good things, bad things, crazy things. So the end, we are here also to put a bit of order on all this noise that sometimes we receive, and to try to clarify why it is useful to use artificial intelligence, how it can help us, especially on the energy management market, and yeah, at the end, put a bit of clarity on this.
Right, because we are wondering what you have heard during last year, but we have received things like, yeah, your work will disappear, robots will take control, ethics, and like we have heard news about everything lately. So let's try to clarify a bit what really is artificial intelligence and how it is applied to energy management.
Artificial intelligence, a broad field of computer science focused on creating systems capable of mimicking human intelligence. It's about trying to mimic our own intelligence.
Right. So the examples we have here are reasoning, learning, problem solving, language understanding. If we think about ChatGPT, ChatGPT mimics human intelligence by understanding what we tell, what we write in many languages actually, and it's able to think the answer, right? So this is mimicking human intelligence, but we don't need solutions such as ChatGPT to talk about artificial intelligence. We were talking before about GPS systems, for example.
Yeah, for instance, at the end, GPS has substituted the need of that copilot next to us reading the maps, but especially when it's not only a predefined route, but something that you want to react to, like the traffic or any other real-time thing that could happen. There is where artificial intelligence is guiding us, and we are just trusting whatever Google Maps is saying to us. So at the end, we are using it despite don't really feel like it's an artificial intelligence behind.
Right, that's totally true. And also, I don't know about the audience, but we have been listening about artificial intelligence, and we also like have heard about machine learning.
Mm-hmm.
What is the difference between artificial intelligence and machine learning?
Okay. So machine learning is a subset of AI that focuses on developing statistical algorithms that can learn from data and generalize to unseen data, regressions, for instance.
Yes. So very importantly, everything that is machine learning, it's basically mathematics and statistics, everything that is machine learning is artificial intelligence. But not everything that is artificial intelligence is machine learning, because machine learning is a subset of artificial intelligence. And you mentioned regressions. I don't know in the audience if there are any engineers around or anyone who have studied a bit of statistics, but I'm sure like many people have done in their lives linear regressions, the simple ones.
Mm-hmm.
Congratulations, you have done machine learning in your life without even knowing it.
Yeah, no.
Yeah, so linear regressions are the simplest expression of machine learning. There are, of course, many models, and this one would be the simplest one, but we can go to many complex models. And the other example we have here, image identification, is when an algorithm tells you this is a cat, this is a dog. This is based on statistics and mathematics.
Okay. So the difference would be that machine learning just develops statistical algorithms, everything based on statistics, and create that algorithm, but artificial intelligence would understand or reason or react to those algorithms.
That's correct. Yeah, very good way of understanding it. Exactly. And now that we've covered these two concepts more like from a theoretical perspective, we would like to be a bit honest with you and show you maybe what you've been hearing or what you might think that is going on with artificial intelligence and what is really going on for companies that are dealing with artificial intelligence.
Oh.
We have here an example of what would be a very complex model, a neural network. They exist, of course, they are used, of course, they are researched, but not everything that has AI in the background is actually using such complex models to perform their tasks. This is a bit of a joke, but have you got any ads regarding
every
this?
every day, and start trying to figure out how this will happen. Yeah.
Yeah.
AI will make us rich, and everything would be automatic, right?
Exactly. Create your company, digital marketing, everything can be done through AI in theory.
Whoa, robots.
Yeah, we have seen so many examples of impressive robots. Some of them are already alive, let's say.
Yeah.
And finally, these are data centers. This is a data center. We have been told that there are millions and millions of data available for us to create data science models with. Is this the truth?
Perfect.
It sounds perfect, ideal. Is that the truth, or what are we seeing regarding data?
Is it any different? Wow, dirty data. What does this mean?
Yeah, so even if we would love to have millions of data available for us and organized, ready to use, the reality is, and if there are data scientists here in the audience, they will feel very identified with this. There are a lot of dirty data that need to be cleaned before they can be actually used by data scientists. And a big part of the job when you want to create a product that relies on data is cleaning, preparing, sorting, ordering all the data that you have available.
It's something I usually compare. It's like if you were studying with a wrong book, right? You can put a lot of effort on training an AI or on training your human intelligence, but if the data you are using for that training is wrong or is not complete, then the result would not be as good as you expected, right? So clean data and have completeness on the data is absolutely key.
100%. Other thing that's happening in reality is that even if we would expect extremely complicated models and we picture data scientists and like doing crazy things, sometimes a model can be as simple as linear regression, like we were saying before. It will, of course, depend on the case, and we will explain later when to use one kind of models or the others. And finally, legislation. Maybe you were not expecting this picture here now.
Mm-hmm. Well, we will see an example where legislation can not only avoid but put you on the way towards simpler models rather than complex AI deep neural networks, for instance, and for good reasons. In some cases, so we will see one that is related to energy management that is driven through legislation.
Exactly. And we have been mentioning, linear regression are simple models. We can have deep neural networks, deep learning in general. These are all complex models. But in reality, once you need to solve a problem and you want to approach it through machine learning models, you always need to choose which kind of model to use. And here we will explain a bit what is the difference or what characterizes simple versus complex models.
Mm-hmm.
Okay, simple models. This might seem obvious, but it's key on the decision of what kind of model to use. Simple models are actually easier to understand and represent. So for instance, for linear regression, you write it in one equation that is very simple to understand. It can be drawn in a graph, like a line, literally. Of course, in order to build these kind of models, you don't need a supercomputer that needs a lot of resources. You can do it maybe in Excel even. And therefore, these kind of models are perfect when there are simple relationships between inputs and outputs, or there are only a few parameters. As an example, if we think about energy efficiency, for example, here we could say,
if it's that simple, because it can become a complex formula, but baselines for energy measuring and verification, for instance, is a clear example of a regression. Okay, and it has good reasons for being that, because at the end it's not simpler, usually better.
well, in some cases, using simple models can drive good results, and that's perfect. For example, if you would like to see if there's a correlation between degree days and your gas consumption in a building, it wouldn't make sense to make something complicated. It's very straightforward, only two variables. But sometimes this relationship is not as simple, and we have many examples actually in energy management. So we should think about complex models when we need good accuracy, like for example, if we want a forecast in order to decide how to operate our building, we might need accuracy. If there are lots of parameters to be taken into account, that could affect very much the complexity of the model. And if you need to explain something that is hard to link, so something that maybe with an equation it would not be possible to explain. As an example, I mentioned forecasting, for example, but we have other examples that would require complex models here in energy efficiency.
Anomaly detection, for instance.
Anomaly detection is a very good example, because in order to find anomalies, you need to take so many things into account that trying to do that with a simple equation that you have created in Excel would very likely not be enough, or provide inaccurate results.
At the end, a complex model would handle more variables, and detecting an anomaly, knowing if it's really an anomaly or not, will need from context data, context information, to really understand the reasons of that consumption. So at the end, that more complex model, we maybe cannot fully understand what's going on inside, but it will become much more useful than a simpler one in those cases where it's necessary. So balancing when it's necessary to go complex, or if a simple model is a better option, is also important in this balance, right?
Very important. So now that we have explained more or less an overview of what does artificial intelligence means, what is machine learning, what kind of models we can find, we will jump into applying all the concepts that we've seen into the energy efficiency field. And we will present to you 4 use cases in which AI has been used actually for ages in energy efficiency.
I like this. Baseline generation. The ones that know spatial energy for a while, you might know that we have a measuring and verification, really powerful module that is compliant with the IPMPP protocol, and it's basically to evaluate, to track, to monitor the savings of your energy measures, right? So creating those baselines is an example where a baseline is usually a linear regression. Why? It's because at the end, the IPMVP protocol is here to help us to share that baseline, to audit that baseline. So the legislation behind the protocol puts us onto creating something that is simple enough for a human to maintain, that can be written into a contract, an EPC contract, for instance, and can be evaluated with different tools such as Spacewell Energy, or why not a Microsoft Excel spreadsheet site, right? So at the end, the value of having something simple enough to be understood or to be modified even from the specialist is a good reason to avoid a more complex model, like could be something like a black box that I don't really understand what's going on behind, right? So this is a clear example where legislation, in fact, is pushing us towards using simpler models. Right?
Exactly. If we take other use cases, we have, for example, where I mentioned about energy consumption or actually generation forecast. In this case, we have many inputs, right? Because in order to provide an accurate forecast, you need to take into account the historical data, like the previous consumption that happened, some calendar information, such as if it's a school, for example, and they close during summer period, you need to take that into account, of course. Then some weather data, especially if there are PV panels installed in the building, and others that are relevant for that specific building. For example, in industry, where production might be key to be accurate on the forecasted energy consumption. In this case, Alfonso, I think we couldn't use simple model, right?
No, at the end, when it goes complex and you don't have some limitations, for instance, regarding to legislation, we should try to decide on the model that provides the better results. And that's something that sometimes, especially engineers, we try to need to understand everything, and it's fine until we find a better solution that maybe we don't fully understand, or we cannot write it like an equation. But when the results are that better, it's important to start using these tools for our benefit.
Exactly. And these two use cases are very straightforward. We included two more. So one would be anomaly detection. In this case, a bit of what we mentioned earlier, finding an unexpected consumption requires knowing what is the expected consumption. And the expected consumption is something that might seem easy, but it's actually not because there are many things to take into account. And of course, you don't want to provide anomalies that are false or that are not really representing a problem in the building. And doing that is pretty complex. And creating consumption patterns and adapting to the daily activity of the building is not simple at all.
Mhm.
And the final use case would be understanding building behavior in general. So in this case,
It's something that is complex for a human to understand how a building behaves, depending on the activity, on the weather, on its location. So I assume that this is another case of a complex model, right?
100%. And actually, this case is very interesting because if you build a model that represents your building portfolio, for example, then you're able to compare buildings between them. And this could let you to understand what's your efficiency improvement potential, for example, or you could even see if there's a building that is behaving in an unexpected way, and maybe that would make you visit the building and see what's going on, check the equipment. So there are many applications if building models are performed correctly. Okay, so now that we've covered these 4 use cases, we would like to focus not on the 4 of them, otherwise this webinar would be extremely long, but we will focus on one in particular, which is forecasting, since we have recently released a forecasting tool here in Spacewell Energy. What is important here is all the theory that we explained, we can want to apply it now to this specific case. Basically, we built a forecasting tool that was using complex models for the reasons that we explained earlier, but there were some customers that expressed concerns If the models were complex and they couldn't really see what was going on inside those models, there was a problem of trust, let's say. How do they know that we are not inventing things, or how can they trust the results that a black box is generating? And to answer that question, we did a study internally where we compared simple versus complex models to show the results and the effect, that this could cause in the accuracy of the results. So what did we do? We took one building, 12 months of consumption, hourly electricity consumption for that building, and then we tried to predict that consumption using 4 different models. The simplest, linear regression, degree 1, a bit more complex, degree 2, again, a regression, something that we can do in Excel and that we can write an equation for. And then we took, within our tool, our forecasting tool, we have many models, not only one. So from these models that we have, we took 2. The best AI complex model and the worst AI complex model. So again, 4 models, degree 1, regression, degree 2, regression, and within our offering inside the forecasting tool, the one delivering best results and worst results. And the question to answer was, which of these 4 models provides the smallest error in the prediction for each month? Just to clarify, a small error means good prediction. It's a bit counterintuitive sometimes. Okay, so these were the results.
Okay, so what we are seeing here is from the best to the worst, that in every single month where the consumption forecasted is evaluated versus the actual consumption, it happens in real time. Every month, the best AI model is providing the best accuracy, the smallest error, let's say, right?
Exactly, and we also see that the other 3 models are actually interchanging positions, sometimes second, third, or fourth position. Okay, so don't worry, we have not invented this data. We will provide more information. So the best model was better by 28%. So the error that we saw with the best AI model was 28% smaller than the worst of the models. 28%, in case you are not knowing the order of magnitude, 28% is very substantial. It's very important, this number.
And this would explain why I should go towards a more complex model. I cannot understand, because the first linear degree 1 or degree 2 regressions, maybe it's something that if I'm technical enough or I've studied engineering, I can more or less understand, I can represent, but it's a 28 or more worse than the AI model, right?
Right, and 28% is very significant, but if we try to represent these 4 models in a graph, then you will see even better what this 28% really means. So what we will have in this slide is the real consumption. This is the real consumption for October from the 12 months that we evaluated. This would be hourly electricity consumption for October. And these are the 4 models that we used in order to predict.
So these are the 4 predictions, one of each model, that tries to predict the actual consumption that is on the top.
That's correct. That's correct. And I really hope you have a big enough screen to see the details here, but we can pay attention to minor details that are very important here. For example, at the beginning of the month, we see that there is a very constant consumption and then a huge peak that is reaching 160 kilowatt hour. And then if we check the 4 models that are trying to predict that behavior, we see that the top left corner model is actually able to see that there is kind of a stable consumption at first, and then there's a peak. The peak does not reach the 160, but the shape is correct and is following the same as on top. Instead, the other 3 models, they are not doing a very good job here understanding the energy pattern that we have. And then another detail we can take a deeper look into is Sundays. Those are Sundays. And what we see is that every Sunday there is a small peak at the beginning and a small peak at the end, and then a stable consumption in the middle. If we check the four models below, we see that on the top left corner, we have the two peaks in an order of magnitude that is coherent with the reality. And then the others, yeah, they are just not managing to get it.
Yeah, in fact, it is like one of the models can really represent. Well, I would say that they even seem the same consumption, right? Well, the three others just don't feel like it's a real consumption of the same building.
Yeah, actually, the three, well, just in case there was a doubt, the best AI model is the one in the top left corner, and the other three, they're actually behaving in a very similar way, which explains why in some months they were occupying one position or another. They are not different enough to say that one of the other three is better than the other. And there's a clear conclusion that we can obtain from this slide, that not every complex AI model will provide good results. Because here, if we were to choose the worst AI model here, we would be actually delivering results with the same quality as if we had done a simple linear regression of degree 1. So it is very important that if you cover several cases, in our case, we cover electricity, gas, water consumption, and electricity generation, one model cannot cover all the use cases. It's just impossible. And it is very important to have multiple models to choose from. Otherwise, you might be choosing the worst AI model unknowing. And then it's the same as if you were doing linear regression, but also you are using a black box, so it's harder for customers to understand. So this study showed that it is very important to have multiple models, that sometimes complex AI models are worth it, and that is very important to understand what you're doing in this case.
I would say that 30% here visually, it comes even higher than expected. I mean, the average consumption of all the models maybe could be like the same in the top, but if you want to operate or take any decision on the forecasting, it's clear that the first one mimics really well the actual consumption that will happen, but the others feel like not that useful to react or to operate the building, right?
Right, 100%. 100%. So in the tool that we have published here in Spacewell Energy, the way that we are calculating all these models is the following. A user creates a forecast inside the tool. This triggers model training. We choose from 14 different models, the one showing the lowest error, the smallest error. And then once we have a model that is trained and calibrated, every day we calculate the forecast, so the real numbers of the forecast that you will see. And finally, this is a step that is very important in any machine learning project. We evaluate the forecast that we are creating. Maybe for users, this step is not as important visually because this is something that has to be done in the background, but it's very important to check if what you are building makes sense or not in order to avoid falling into this worst AI case that we saw earlier. So evaluation sometimes is as important as training the models. And after all of this that we have been explaining, how do we see this in the platform? So basically users have a form where they can choose the building for which they want to forecast and the meter or the kind of energy that they want to represent. And they can also choose the inputs that they feel are important for the model to predict their consumption or generation. For now, you see weather and calendar data here. In the future, we might be including other kind of inputs to better represent other buildings. Once the forecast is calculated, then we can visualize it in any screen. If there are partners in the audience, This is a forecast parameter, so it can be included in any analytics screen, dashboard, everywhere. It works as any other parameter in the platform. And last but not least, since we are using complex models, which means we cannot write an equation for users to see exactly what we're doing, we have created this section that we call traceability, which is to provide you with more information. Here, what we are telling you is, first of all, what model we're using and what metrics we are getting from this forecast, so you can check and see if you trust enough the results that we provided to you. But also, from all the inputs that you chose that are relevant for the forecast, we tell you how relevant they actually were, the weight they had inside the model itself. In this case, the week was very important and the hour as well. We have to think that for offices, for example, the hour of the day really determines the consumption that the building will have, sometimes even more than meteorological parameters. So that would be it. Just as a quick comment for partners in the audience, this feature is already launched, is in production, and it is available for advanced and ultimate licenses. Okay.
So something that we've said, when you get a better results, you should try to avoid controlling everything towards relying more on the more complex models, because they will provide better results. But we also want you all to trust the results, so that traceability is something that you should ask for when you are also relying on AI for your business. So that's why these metrics and is important for us to provide to you, so that you really understand what's going on, at least on the analysis of the results.
Exactly. At least trying to be, since the model doesn't allow us to present it or show it to you, at least be as transparent as possible with you, to ensure that you trust what we are doing, and also for you to have your own criteria in deciding how this model is working for you based on real results. Exactly. But what about the other use cases that we mentioned? Do we offer anything?
Do we have? Well, we've been working with AI for a while in spatial energy, in fact. This is the automatic baseline calculator. We've talked about that. And let me say that having a simple model, like it could be a regression, it is simple, but it is not that easy. I studied statistics at the university, of course, but it's not my expertise area. So for me, creating a regression could be something really complex. So here the key, when you use statistical tools like ABC, is that do not try, as I mentioned before, do not try to control, to fully understand what's going on in every concept, or if it multiplies or gets to the second degree, because rely on statistics. The better the regression or the better for you. So at the end is where these tools can really help you. Okay, so it's simple, but it doesn't mean it's easy. So having this kind of tools could save us tons of hours on investing on creating this, and have a much better result also.
Yeah. And in another use case that we have is a product that is called Detect. Detect is a benchmarking tool. So it creates models to compare buildings that are similar one another. And thanks to this comparison, then we are able to provide an improvement potential. And then this is taking into account the use of the building mainly, where is this building located, and other parameters to ensure that the comparison is fair. And of course, in order to compare buildings between them, you really need to ensure that the data from those buildings is to be trusted. And that's why we have a very in-depth analysis for each data quality, which is the picture that you are seeing on the right.
And also for you to really monitor or to be aware of the quality of the data you are sending to the platform, its completeness, its its quality. So it's also important for you to really understand what data are you using.
Exactly. And finally, we wanted to mention Optimize, which is our anomalies detection engine. Today, this engine, what it's doing is trying to find unexpected consumption, taking into account the behavior of the past, meteorological data, and calendar data. We are now working on improving this product even more. So if you're interested, stay tuned for the updates that we will be releasing. And I know we went very fast through these three products, but we could stay here for 2 hours. And I think you don't plan on staying all your day listening to us. So I will now hand over to Kashif for 1 second. And I wanted to be grateful to all the people that have stayed until this moment. Kashif.
Yeah, thanks, Julia. That was really insightful. Uh, I mean, if there's any questions, please feel free to drop them in the chat and we'll answer them. Um, Again, I think it was a very valuable session. We gained practical insights on how AI can help you optimize energy management and achieve your sustainability goals. As a next step, if you'd like to learn more about how spatial energy can support your organization, feel free to contact us directly and we can arrange a custom demo to show how our platform can meet your specific needs. Additionally, we are really excited to announce that we are organizing a Spatial Energy Day in London this May. And this is an exclusive event which will bring together industrial leaders to discuss the latest innovations and strategies in energy management. And we will be reaching out to you soon with more details. And I look forward to staying in touch and helping you on your journey to a smarter, more efficient and energy management. Thank you again and enjoy the rest of your day.
Thank you, Kashif. So we still have 3 more minutes to answer your questions. So I think we won't have time to cover them all since we received many, but let's start from the beginning. We received a question from Carla. Um, they are asking which error analysis are you using? There are many metrics for error that we're taking into account, but the main one and the one that is used inside the tool to decide the model to be used is root mean square error, but we also use MAPE, all of them, MSE. We take them all into account. R-square is included as well. And regarding which variables we are using for the linear regression, I guess this was referring to the analysis we did. And they are exactly the same. So we used meteorological variables, temperature, and anything that can be derived from temperature, pressure, solar radiation, and any derivative.
Dew point, I've seen also.
The dew point, yeah, like any weather variable that is available has been used. And then calendar information, which means hour of the day of the week of the year, month of the year, and if it's a bank holiday or not. These were all the variables that have been used. Okay, this actually answered Ray's question as well. Yeah, we use root mean square error mainly, but the others were taken into account as well. Carla also mentioned which AI model we're using. I don't have exactly the name, but I have some examples of models that we are using. Light gradient boosting is a model that we've seen is chosen many, many times, actually. It's providing very good results, especially for offices and for electricity consumption. But you have here name of 2 other models that we've used. We have, of course, the full list and how are they used within the platform, but this should be answered offline. Then we have more questions from Andreas, and they're asking how much historical data is required for training the model. This is an excellent question because the answer is it depends. So if we have an office which has a very stable consumption and a very stable pattern of Monday to Friday and then Saturday, Sunday off, we don't need that much data. Like maybe even 2 months of data could be enough, especially if there's not a lot of changes depending on seasonality. But If you have a building that changes its consumption very often or that is highly affected by the month of the year, because, for example, it has heating through electricity, then you need at least 12 months of data in order to make an accurate description of these changes in seasonality. And I'm sorry because there are many questions, but we have time for only one more. So Grace was asking if this model works for any building type. Yes, this model can work for any building type, but because we have 14 different models, if we had only one, then it would not be good enough for some cases. However, if, for example, you have an industrial site and you have your consumption driven by your production internally as a manufacturing company, for example, then we should definitely include your production forecast in order to do an accurate forecast for you. The way that this tool is published right now is taking into account meteorological parameters and calendar information, which is useful for the tertiary sector mainly, which includes a lot of verticals. But in the future, if we find that there's this need, we will definitely include additional parameters to, for example, cover industrial sites. In the case of supermarkets, sometimes we've seen that the consumption is driven mainly by the amount of refrigerators that they have in the supermarket. So that could be another example of building that would require specific data to ensure accurate results. And I'm very sorry because I see a lot of questions. I'm very grateful to receive this amount of questions. Thank you for paying attention and spending your time with us today. We will have to reply, unfortunately, to all these questions offline. I don't know if anyone else would like to add anything, but that would be mainly the end of the webinar today.
Yeah, I think just on that, there are a number of questions about the event as well. We'll definitely send you the details around the event in the next coming weeks. Well, thank you all. Enjoy your day.
Thank you for
very
your
much.
time. Bye-bye.
Bye.